Have you ever walked down a New York City street and looked up all the buildings in amazement and wondered how exactly do they actually build such large structures in such a small space? How do they get all the materials there? How do they get all the workers in a square block in order to build a couple 100-foot tall building? Well, this was all done through traditional project management. So traditional project management is this sequential cycle management where everything has clearly defined objectives ahead of time. If you're building a skyscraper, you design the entire skyscraper, all the risks, all the objectives ahead of time before implementation. You don't change anything once you start actually building. What this does, it allows for very controllable processes so everyone knows exactly what they're responsible for. They have accountability for what they're responsible for, and they can control everything involved in the project. So the phases of traditional project management is first you initiate it, where you figure out what your requirements are, what your stakeholders are, what exactly the problem is, criteria, constraints, and you go into planning, which is actually start designing the skyscraper. From there, you go in the execution phase, which is the longest phase. You go and actually build the skyscraper. From there, you actually monitor the entire skyscraper and figure out if there's any issues. If there's any mistakes, you go through the change control board to fix those mistakes. Finally, you do the closure and reporting to your stakeholders. And this is different from an agile project management where you can actually change anything during the design and testing phase. So when do you actually use traditional project management? So traditional project management is used on high risk or very large scale projects. Agile project management is used on very small or medium scale projects. And for a large scale project, you design everything before implementation. If you're designing a rocket, you want to know exactly what that rocket is going to do in orbit before you launch it. And what this allows for is very low client involvement because if you plan out everything ahead of time, your client shouldn't have to be there when you're actually executing the project. They should only be there when you're actually planning out the project. And usually the manager or change control board resolves any issues during the project. In the upper right hand corner, you can see Spatial Columbia. Unfortunately, Spatial Columbia broke up in the atmosphere on reentry in the early 2000s. What happened was, on liftoff, a piece of foam came off the main booster tank that was carrying all the fuel. It hit the wing, and the engineers requested they actually tell the astronauts that there was a hole in their wing. Now, the change control board decided to just not do anything about it. They decided to not review the incident at all, and they completely ignored the engineers. They didn't follow their traditional project management for a large-scale project. And what had happening was when the Spatial Columbia re-entered the atmosphere, it broke apart at 18,000 miles an hour, and that killed all 9 astronauts on board. So if you're going to use traditional project management on large-scale projects, make sure that your manager or higher up in the project always is resolving issues. Don't just have a hallway conversation and ignore some high-risk situation. So the structure of traditional project management is functional or central organized, just like we use in class. You have the CEO, which is reporting to or talking to all the functional managers, such as your project leader or project manager, and then that's talking to all the staff within each project. For example, if you're the project leader, then you have the director of administrations, director of communications within your own project. So you want to make sure that everyone is communicating up to the very top, and the CEO is in charge of all changes. He's the final person. Now, with project controls, if you plan out everything ahead of time, you should be able to predict the outcome of your project. So the first thing is with any of these project controls is reporting. So you want to make everything simple to understand. When we make our Gantt charts, we don't just make a giant spreadsheet of all our dates. We actually put it on a very easy to read and very easy to understand format. And you want to hand this to your stakeholders so they understand this easily. So planning and scheduling, use a Gantt chart with easy to report data. Well, not easy to report, easy to view data on a Gantt chart matrix that shows exactly who is responsible for what on the project ahead of time before you start building. So for risk management, you have to make a risk management matrix in order to understand what risks are associated with the project. So risks are how you get scope creep, because what happens is you go to build your skyscraper and you didn't account for a risk. You didn't account for the wind at the top of the building affecting the structural integrity. So you have to go back and redesign everything. You have to go back and find new suppliers for new different types of concrete, and that just affects the entire scope of the project. You put way more deliverables on your project without more time and budget. So you got to account for exactly all the risks ahead of time. So project scope and change management. So whenever you want to make a change to your project, for example, with the concrete I mentioned before, you want to make sure that you can actually calculate that effect on the scope ahead of time. And you go through a change control board. In the image you actually see NASA's change control board method, where the engineer or the originator makes a change and request a change, and it goes through a very lengthy process of many different engineers and change control boards and responsible organizations in order to understand exactly how this is going to affect the final product. And this prevents scope creep, so you understand all the risks ahead of time. So for earned value and control baseline, so if you plan out everything ahead of time, you should be able to figure out what your planned value is or what you should be able to accomplish with a certain amount of time and a certain amount of cost. And you can actually graph this, and this graph is called the baseline. Now, this allows you to measure the schedule, scopes, and budget. For example, on this graph right here, you can see the blue line represents our planned value, what we got during the planning phase. Now we actually went to go build this. We saw the red line. This is actually what it actually costs. It costs more than we planned for. Then we have the green line right here, which means it took a longer time. So we have more cost and less time, more time was used, and we earned less value out of it. So in order to actually correct this, we'd actually use a change control board, figure out what's wrong with our project to try to get back on this blue baseline. And from here, we actually have document control. So let's say we have 100 people working on the same project, and we have one document that everyone's looking at. Everyone's looking at the same team charter. So how do you actually manage that? So the way it works is you have your main team charter as your master, right? And what happens is anytime someone wants to make a change to it, they make a branch or like a copy of it. And what happens is you make your change and then you try to push your branch back to the master branch. And what happens is if the change control board approves your branch, then your branch becomes the master branch. And then someone else could be doing the same thing. This allows 100 people to work on the same project at once. Document control then brings us into building information and modeling management. So let's say you're designing a hospital. This is a very big building with a very large scope. You could have many, many different companies or even countries working at the same time. With LAX's $12 billion upgrade, there was 33 different countries working on that same 3D model. So how do you actually manage that? So instead of like Google Docs where you just make a copy of the document and then you try to manage all those different copies, the way you actually do it is on a program like Autodesk where they actually go in, they make one central 3D model, and just like we discussed before, they make a branch of that 3D model where someone makes a change. And you can try to push your branch back to the master. And what happens is the Autodesk will actually highlight any errors. If two measurements are off from the original, it'll highlight that error, and the change control board can figure out exactly which one they want to pick. Now, you might be wondering, if you have such a large-scale project, how do you make sure it's actually going to work in the environment? So we've only ever worked with 3D models. A 4D model is what happens is we get a 3D model and simulate it over time. So for example, you get this hospital and you can simulate a flood or a fire on this hospital, and you'll be able to figure out and show you all the damage that will be done to certain components because you actually go through and add this part is steel, this part is wood. And that helps project managers to understand the implementations of their project 25 years into the future. And this also allows suppliers and engineers to collaborate on exactly what their project will look like ahead of time. So the supplier performance. So stakeholders are people who provide resources to your project. A supplier is someone that will provide actually equipment. For example, when working on a skyscraper, someone who's going to provide the concrete trucks are a supplier. And those people are also stakeholders because they control some part of your project. Now, when you're working with a concrete truck, for example, the actual cost of the equipment, the upfront costs are only 35%. The actual cost of ownership for the entirety of the time you're going to own the equipment is the rest of the 65% because you have to worry about maintenance, where if it breaks down, where you get more materials to fix it. Now, you can actually measure supplier performance using that same baseline metrics or graph I mentioned before. And this allows you to understand exactly where your project is on the timeline. So the triple constraint is a very helpful tool and a very helpful visualization that actually helps you understand the scope, cost, and time of your project. What you do is you put the scope, cost, and time in one big triangle, and the actual output of the scope, cost, and time is your quality inside of the triangle. So, for example, if you change your scope and you don't increase the cost and the time, then the triangle becomes lopsided or uneven, which means you have too much you have to deliver and not enough cost and time. You always want to keep your triple constraint as a perfect triangle. Scope creep is when you don't have enough of any one of these three to complete your project. If you don't have enough time, but you have enough scope and cost, then you need to increase both your scope and your cost to account for the extra time. So this is going to increase or decrease your quality based on the changes that you make. So far, we have learned that traditional project management is a sequential cycle where everything is planned ahead of time and then executed. We learn how to use on very large scale or high risk projects where everything needs to be understood ahead of time. And we have various project controls that help us to make sure we manage all of those factors ahead of time, such as how we're going to report it, how we're going to plan it, what are the risks, the scope, what's the baseline, what's the building information management, and what's finally, what is the triple constraint, and how does that affect our project. So understanding all of these qualities will really help us to figure out exactly how we can plan on a very large scale project ahead of time. Thank you for watching my presentation. Any questions?